no buoyant force in the air. There is no buoyant force at all. So you have the pure weight of something. With air, there is a little bit buoyant force, not much, but therefore it gets lighter. And if
This
you
is
have a
All
very
right, man.
dense air, it's getting even lighter.
this is why I
Okay,
don't
so
believe
you know that the Earth's rotating by the gyroscope. You're saying, well, you know 100% the Earth's rotating because of the gyroscope, or do you still not know?
Yes, you know. I would say you know.
100%. You know the Earth's moving, Earth's rotating due to the gyroscope.
The thing is, with 100%, you're always pointing to this 100%. So with very high certainty, yes. Unless something that we have not yet figured out is in the way.
So there's a chance it's not moving. I'm
There's a
playing Jeremy
chance
now.
that unicorns, rainbow farting unicorns exist, but the probability is super, super low.
Oh, so you had to go to rainbows and okay. So let me ask you something. If I take if it's a nice hot summer day and there's a fly on the table and I take a fly swatter and I squash it, bah! Is it 100% the fly's dead?
How many milliseconds after you squashed it?
We'll give it a minute. We'll be generous.
I have seen flies pretty amazingly still moving after a long time when you thought you have hit it. So I would say I have not enough information about how hard you hit it.
Let's say you saw legs flying, wings, and it was like a paste. Like you're gonna tell me this is the best argument I've ever heard, to hear them say things like this, man. This is what regular people need to hear. Right?
Yeah.
You squash the fly, it's paste, and they're saying, well, maybe it's still alive. It's not 100%. Yeah. This is the arguments people need to hear, my friend.
The sir could be decomposed. Still be like, yeah, it might not be dead.
Yeah, exactly. The way he's laughing now, that's what it is. It's reducto ad absurdum, reducing an argument to absurdity.
So in the case of
Come on,
tree,
go ahead.
I was going to say, in the case of the tree and the car, it depended on the reference frame. So if you fitted a GPS tracker to the tree, regardless of the reference frame, we could establish that the tree is never ever going to move, whatever reference frame you could even think of.
The funny thing is the GPS trackers, so the GPS satellites are in the reference frame of the Earth. So a point on Earth is always showing, except of the margin of error.
When do you ever get out of Earth though? When is it a point when the tree is actually moving?
Well, the tree's always moving, isn't it? In their paradigm,
yeah.
So
right after the fly gets up and starts flying again after you paste it.
But the tree could never move. It must be the Earth moving because the tree is in the ground with its roots.
But the tree is on the Earth, so it's moving with the Earth.
Yeah, that's what I'm. Yeah, this is the nonsense. What you need to say all that, because when you're just saying the tree, we don't know whether the tree's moving or the car. Now you say it in a way that's understandable because you think the whole Earth is moving. But do you know that's?
Yeah, the Earth is rotating and it's moving, and the galaxy is moving, and the solar system is moving, and so on. But the point
Beautiful
is,
story, my friend. And you've never proven this.
But the point is, when the car hits the tree, it doesn't matter if the tree is moving because it's all on the reference frame of the Earth.
What about reality reference frame? Yeah, have those.
Your reality is on Earth, yes.
You should do you have any? Because I mean, y'all always say, "Oh, the reference frame, the reference frame." Can y'all come to reality reference frame? Because that's where we're always at. Is nowhere other than reality reference frames.
You should rephrase it from their perspective. You should rephrase it for them to: is it moving in respect to the entire universe?
Yeah, it's the same. Like if you are in a train and the train is moving with 300 kilometers per hour, and then I'm just going towards you, and I push you or so. Do I push you with 300 kilometers per hour, or do I push you just with, I don't know, 5 kilometers per hour? Because we both are moving in the train.
You've reiterated this concept maybe 10 billion times. What about if something is, okay, just imagine something is moving, right? Anything.
Are we talking about reference frames, or are we talking about the Earth is moving?
Anything is moving with relation. The delta between two objects is increasing. Any two objects, whatever, right? The delta between
the two objects relative to each other, not necessarily the delta.
The delta between two objects is increasing. That's going to be regardless.
The delta just means difference.
The delta, the difference in space between two objects is growing. Okay?
So the delta distance, or what?
Yeah, exactly. The distance between two objects is growing. That's going to be in any reference frame. Now, is it, I'm not saying whether you can tell it's the case, but is it the case that either one of them or both of them are moving with relation to the entire universe? Choose your answer.
Yes. All is moving into the relation to the entire universe.
Did you say yes?
I think so.
Yes.
I don't even know, dude.
Okay.
It's relative. Hey, that's actually a relative answer.
No, but so this guy's committed himself to the fact that then therefore there is absolute motion. It's just that he believes you can't tell whether one is moving or the other. But you do believe that it is the case that one of them is moving or the other is moving. Like it is the case that either of them is moving or none of them moving. It's not like relative in relation to
none of them moving cannot be if the distance between the two are changing.
Yeah, sure, exactly, true. So it has to be the case that either one or both of them are moving in relation, and it will be like it will be one of those two. It's not going to be relative. It's going to be like either this is moving, both moving, or the other one is moving. But it's going to be absolutely the case that any one of those scenarios is true, right? With reference to the entire universe.
Yeah, probably both is moving.
The tree is moving.
The thing is, if you're in the belly of a ship,
I've been trying to get in.
Yeah, and let me finish my point. Because that's establishing that the guy believes that there is absolute motion. It's just that you can't tell. That's actually against relativity, by the way. Relativity says there is no absolute motion. So you don't actually believe in relativity. It's cool.
Can we talk about gyroscopes a little bit? Because I don't really understand them.
Then why you want to talk about them if you don't understand them?
Because I want to learn, Elbow. That's oh my god. Isn't that why we're here? That's why I'm here. That's pretty clear. You're not here for that, right?
Can we talk about how Dave just turned around and flip flop on the 24 hours on TFE?
Well, let me ask Doofus one question, or Snooze. One question, right? If you turn the entire thing upside down, so you grab the whole gimbal and you turn it upside down, will it rotate in the opposite direction?
Wait. About what kind of gyroscope are you talking about? Like rotary gyroscopes or what?
Well, this is the thing, isn't it? What are the principles and how they work? I don't even know that.
And so you definitely have to distinguish between, for example, a normal gyroscope, where you have a disc like a flywheel or so that is spinning, and therefore kind of establishing a kind of a plane, or how do you say, an inertial motion? I don't know. So like it stays still. And the other thing are these laser gyroscope. So the thing that Bob Nodell, for example, used was a ring laser gyroscope. The thing that is used in modern airplanes to do navigation is a ring laser gyroscope. There are no moving parts. There is no gimbal.
There's no. Oh, okay.
I thought those things in airplanes don't work.
So does that?
Yeah.
Does that work on the Sagnac effect then? The laser beams.
Yeah, it's lasers. Lasers are kind of projected in a ring, and because you have lasers going in both directions, one's kind of clockwise, the other one's counterclockwise, simplified terms. And when you then turn something, the laser that is, for example, you turn something clockwise, so to the right, right? So the laser that is going also clockwise is now traveling a longer distance because it was sent on its way to go clockwise, and then you turn it so the goal where it ends after one full rotation has moved a little bit. So it has a longer traveling distance than the laser that has been sent counterclockwise. It has a shorter traveling distance. Therefore, these two light waves are not overlapping each other perfectly when they reach their kind of destination, and that is what you can measure.
Right. I kind of get that. What about the mechanical gyro then? In a plane, do they have both?
In old planes, these were I think INS, the inertial navigation systems. They are normally referenced to have these mechanical gyros, and the IRS, they are these ring laser gyroscopes. These are the modern ones.
Right. Because I remember when going back some years, I remember when I first heard about this and I was thinking about it, I thought that, and I might have mentioned it quite recently because I haven't sort of fully fleshed it out in my head, but I thought once they get to the equator that thing had turned over, right? I thought, why isn't this gyroscope turning over? But I guess it's because gravity is acting on it all the time, right? I'm assuming.
Why do you think it's turning over?
Because
so this
I just thought. Because
okay,
I thought the whole point of the gyro was to keep rigidity in space, and so I thought that it was turning over. Yeah, but I realized quite quickly, once I thought about it a little bit, that you're always on top of the ball, aren't you? So it's not going to turn over.
Yes. So with a normal INS, so the old mechanical system, it has a kind of increasing inaccuracy how every time you travel longer. So let's say per 100 miles traveling, you have kind of a discrepancy of 2%. So if you have an intercontinental flight, it's pretty inaccurate when you are at the end. These new systems, the laser systems, are pretty accurate also over long distances. However, this kind of going over the equator, these gyros has nothing to do with the rotation of the Earth. So the old systems, as far as I know, are not accurate enough that they can automatically detect all that stuff. Not sure actually if that would be enough.
Yeah, I remember
however,
Left Lane saying how he had to sort of reset his every 15 minutes or something like that. I can't remember.
I think the old ones need a longer time to actually calibrate, or maybe they actually detect. I think I read something like they need half an hour to calibrate where they are, or on the position of the plane. However, the change with the equator has nothing to do. We are still going clockwise or counterclockwise, depending on from which direction you look on the ball.
Is there any way we could determine, because we've got a lot of things turning in the opposite direction, right? That's
the thing is,
I see this as good evidence for the globe. However, let's just say it's something else. Let's just say, I don't know, I have no idea what it could be. These huge masses that are turning above us are importing some kind of drag and making things turn. Is there any way we could sort of, isolate one to show what it exactly is?
Wait a second, just one thing regarding equator. For course, pendulum wouldn't work on the equator.
Yeah, so I keep hearing. Has anybody actually done that though?
And for course, pendulum at the equator?
Yeah.
I don't know.
I mean, it seems like, I don't know, I keep hearing this claim and then they're like, well, what's the point? It's not going to actually do anything anyway. It's like, well, I want to know though. I don't want to see it do.
These pendulums, what you definitely can look up, these pendulums go in the one direction on the northern hemisphere and the other direction on the southern hemisphere.
Mm.
And I think they just don't have one at the. Maybe they have in one museum one at the equator to show that's not working properly, but that is definitely something that you can see. So look up some Foucault's pendulum in Australia or Southern Africa or so.
Yeah.
You will see that it has a different rotating speed, and it's not that you kind of push the pendulum in a turning motion. They are kind of moved to the side, they are locked, and then they are just dropped, and the dropping is always going to the center point. That you, without a push sideways, you can't bring them in rotation movement. So there is no fake on these things.
What about Tenerife? Is that going to be any
I've got
value?
the best gift ever for that.
Again, please.
Tenerife, is that out of too far up?
I didn't understand it or get it.
Tenerife.
Tenerife.
Yeah, is that going to be too far up or not enough south?
Actually, I have to look, but I think that's enough north. Tenerife is not so far south.
Well,
what's the cause of the precession
right?
and for it going in different directions? What's the cause?
What's impacting upon it?
What's the cause of the Foucault's pendulum going in the other direction, or what?
Yes. What's your cause?
Rotation of the Earth.
And how do you falsify that?
Going to the equator?
No, you'd have to stop the rotation of the Earth. Wouldn't you agree to falsify it?
No.
Okay, nice talking to you. So if it's your cause, if it's your cause of the effect, to falsify it, you'd have to manipulate it.
No, for example, like you can figure out the cause that it's light during the daytime by looking out, and then looking out another time during daytime, you see, okay, the sun is causing the light on the daytime. So because when the sun is at the sky, it's bright. When it's not, it's not. So you don't have to, with your independent variable, you don't have to alter the cause. You just exclude the cause so that you can then verify that it's actually causing it.
I didn't think,
for example, with the Foucault's pendulum.
This is not an experiment, though, right? I thought it wasn't classified as an experiment.
What, the Foucault's pendulum or what?
Yeah.
I don't know. Maybe, I don't know. But the point is, with the Foucault's pendulum, the location where you do it is an independent variable. And this you can change. And you can go to the equator and it would not move, and you can go south of the equator, it would move in a different direction. And then the speed of the
cause, the movement, the rotate. You said your cause was movement, rotation of the what it's on the Earth. Now you're switching.
Yes. The root cause is the rotation of the Earth. Then from that one, you can then go to what is causing it being faster or slower. So, for example, on the North Pole, it would exactly rotate 15 degrees per hour, or was it 15? I don't know, but like it would be turn once in 24 hours. But on the other positions down to the equator, it goes slower. So this is stuff that you can verify and you can measure, and you can make experiments with that. So the cause of the speed is the location on the Earth due to the rotation of the Earth. It's not a proof, it's evidence, because science is not proving stuff, science is bringing evidence.
Is there any way it could be something else, though?
Of course, magic.
I didn't say magic. You said, come on, you know what I meant. There might be something else, right?
Could be magic. Why not?
Well, there's a lot of people that think that the sky's moving and not the Earth, right? So could that be imparting some kind of force down to the ground?
Let me ask you a question. Have you seen the guys with the bucket and the water, and they move across the equator? One way it spins clockwise. When they move the other side, it's go anti-clockwise. You've seen that, yeah?
What? When they pouring water into a faucet?
Right, they got a bucket, yeah? And they put the water in the bucket, and it spins one way. And then they go walk across the equator in South America, and they do it, and it spins the other way.
No, that's been debunked pretty thoroughly, I'm pretty sure.
Yeah.
No, that should work also. If it is.
No, it's
what the water. No, it can't be, though. If the Earth. No, I'm going to get it out one way or another. I know what you're talking about is a trick where they walk like 10 feet. But if you put water in a bucket and pour it in, like you start it moving, just like you do the pendulum, it should process in a way that whatever it's on, Earth, is moving. And if you change that location, it should move faster, slower, and in different directions if you go above the equator and below the equator. Absolutely should. Precession is no different, whether it's something swinging back and forth or moving round and round.
Yeah, but you could have that pendulum, and you could hang that pendulum. As long as you don't touch it, it's never ever going to move. So what does that prove?
What do you mean?
The pendulum isn't going to magically start to move. That's for sure.
Yeah, but if you swing it back and forth, it's going to process. I don't deny that.
So,
Slitzy, do you mean like a hanging pendulum, just like a plum, or what?
Any? Well, what's your idea of a pendulum?
I mean, it's moving forwards, backwards. That's the difference between a pendulum and a plumb bob, right?
Okay, well, no, because like a pendulum is moving because it has a mechanism. Yeah.
No. This is a metronome or a clock,
right,
something like this. But no,
a grandfather clock.
Pendulum is just like a plumb bob that you brought in motion.
So let's go for a grandfather clock. Yeah, it has a pendulum. It doesn't magically start kicking or moving. It's on a mechanical thing. How it processes. So like it don't just if you don't wind up your grandfather clock, the pendulum stops. We agreed on that, yeah?
Yes.
It doesn't magically stop.
So that the pendulum on the clock is kept in motion because there are weights.
Okay.
Like weights or springs, and these weights and springs are kind of giving it a slight push every time.
Okay. So whether it's a plumb bob or whether it's a pendulum, it doesn't matter. If they're not moving, there's no difference between the two. It's only with that the pendulum is part of a mechanism and a device, whereas a plumb bob is something you pull out of your pocket and just hang it down.
No, wait a second. You're misconceptuating what the pendulum that we are talking about is. We are not talking about something in a mechanism that moves forwards, backwards. We are talking about a weight that is mounted on a long string, and that is just hanging from the ceiling. Exactly like a plumb bob. There is no mechanism. Wait a second. Just wait a second, please. Just for a moment. There is no mechanism. There's no mechanism at all. And the Foucault's pendulum is just a very long plumb bob that is once kind of pulled out of the center of gravity, and then you let go.
In other words, you have to move it. It won't move by itself.
So in other words,
it won't move by itself. If you just let it hang, it just hangs still down.
Yeah. And
so that's the mechanism. There you go.
There's no mechanism.
Yeah, you are the mechanism. You had to start it up.
Yeah. If you don't start it, it's never ever going to move. So how can you then say it's because of Earth's rotation?
No,
because it's not how it works. They don't claim it's moving because of Earth. They don't claim it's moving because of Earth rotation. They claim that it's precessing. Do you know how
the forwards backwards motion? Let's say you pull it south and then you let it go. It's going south north all the time, and while the Earth is moving, that south north angle is shifting, more going to east west, and then going to north south, and then going to west east, and so on. So it's rotating. This angle or this direction of swinging, this forward backward swing, that direction is turning. And the turn cannot be introduced by something from the outside except of air movement, which you can exclude there.
Pendulum has a lot of uses, also for dowsing.
So really and truly, you can't, regardless of how you hang that pendulum, it's going to be attached to Earth in some form or another. There's no way that you could magically just hang it in thin air.
Yeah, sure. It's connected at the ceiling, and the ceiling is part of a building that is standing on the floor.
So That's like when you're talking about your time frame. It's connected to Earth. So what does it prove? It doesn't prove anything.
It proves that this frame where it's connected to is turning below this pendulum.
What about those? You know, like when you get those.
No, it's not proving. It's bringing evidence.
Well, yeah, I was going to say it's not proving anything. Well, you know, you get that like the toy in the office, and you've got the ball, and you let the ball go, and they go click, 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 click.
Yeah, the Newton's pendulum. It's not going forever. It's pretty.
Yeah.
So you're introducing energy into the ball that is hanging by pulling it out of the center of gravity, but you're not pushing it into the motion. You just let it go, which means like gravity is trying to pull it back to the center of gravity. But by that point, when it is at center of gravity, it has a certain velocity, and therefore it goes over the center of gravity to the other
you're
side.
saying,
just like your earlier Newton's pendulum, it doesn't swing forever. This is just like that. So it does have to be constantly, generating back and forth motion. It'll stop too fast to measure anything. If not,
that's why you typically hang these Foucault's pendulums are typically on a very, very long string, so that the kind of angles that are breaking it are very low. So it goes for some hours.
No.
So Andy, did you learn anything yet?
Yeah, I did. There's a lot of things turning in the opposite directions, and the globe seems to be the simplest explanation. And nobody seems to be able to rack the brains to tell me something else that it's going to be. So I don't know. I don't know what to tell you.
We're doomed.
So the globe has the simplest explanation. That's what you think is doing that.
Yeah, I mean, what else could be turning the things in opposite directions?
What happens when they bring the eclipse into play with the pendulum? Doesn't it just flip the other way around?
I never actually saw that. Brian said he was going to do it, but I don't think he ever did he?
That's how the story goes, man. It's a bunch of stories. I mean, it depends if you want to buy it or not.
An eclipse changes the behavior of a Foucault's pendulum?
Supposedly. I can't remember. What's the name of that? I can't remember.
In my opinion, we'd have to do it with more material, right? Like they have this. They have
it's the Elias effect.
The Elias effect.
Elias, that's it,
More materials, right? Different materials at different density, because these different materials have different charge to it. And if there's like an unequal charge distribution in the air, it can affect it. If there's a rotation of charge in a specific direction, it can affect it. I think I remember was it Sleeping Warrior who had done it with a few guys in the garage, and they watched the pendulum go left to right to left, to a circle, all sorts of stuff. Or was that
in the garage?
I think it might have been Cavendish they were trying to. No, it was Cavendish, not a pendulum. My mistake. But
yeah, and Cavendish is not that easy to replicate, actually.
None of these are, yeah.
No, I mean, if you have a high tower, a Foucault's pendulum is pretty easy to replicate, but you need a very high tower and a long string, and you want to attach that long string to something that can rotate, that is kind of freely rotating at the top, so you won't kind of introduce a steering or so.
Yeah, I mean,
they are all.
I mean, it's not. None of these are easy to do. The Foucaults, the Cavendish, none of these are easy to set up to eliminate all sorts of variables to say, well, this is definitely the cause of the effect. There's not enough of them. They're not easy to replicate to do this with. But to attribute it to Earth spin and nothing else does seem unreasonable when we have so many different things going on in reality, like so many fields, or like it's definitely begging the question, big time.
No, it's.
And when we have other demonstrations of like things like pitch data, planes, destinations, when you account for going to a destination, never having to account for Earth spin with a hot air balloon, anything else, it would be, in my opinion, it would be irresponsible to attribute this other occurrence to Earth spin when nothing else does it.
That makes sense.
Oh, with the
Snooze, are you gonna tell us that no, it isn't begging the question?
Yeah, because the point is, you can support ideas or theories by doing experiments. So if you say, and this is the experiment with the Foucault's pendulum, if you would say, okay, if the Earth would be rotating, that thing would exactly behave like this, and you can verify it, and you can verify it on different locations on the Earth. And no, it's just confirming the theory. It's not saying it's confirming the theory, and then you can try to find other possible causes for that.
All right, bro. So the
Elias effect, try to eliminate them. So it's
Elias effect falsifies your assertion.
What?
Unless you're trying to say that the Earth stops moving or starts moving backwards during an eclipse, it falsifies your notion.
Riggs, what's the Elias effect exactly? Or what's been shown with that?
He posted.
It was posted. It was posted. I have to read that. Never heard about it.
Could you give like a summary on it?
It's just that the effects of the precession changed during an eclipse.
Interesting.
Let me just read the first little sentence. It says, the Elias effect is the alleged anomalous behavior of a pendulum or gravimeters. So it's anomalous.
Yeah, well, they say that.
Yeah, go ahead,
bro. They say that because it's not well known, and if it were well known, it would falsify the globe assertion. I think it was Caltech that did this, replicated the Elias effect for like 17 years.
So, I mean,
it's not alleged; it's confirmed.
So is it when the moon? What is it when the sun is eclipsed, or the moon goes through
a sun eclipse? Moon eclipse wouldn't make any sense.
Well, I don't know.
So the thing is, I have not read it yet, but how pendulums work is like the gravity. And don't go nuts now. Just I use the word for the thing that pulls down. So the ball is pulled down towards Earth, and when you go out of the center, the string is basically like lifting the ball because it goes diagonal. Therefore, it's going against the downwards motion. Therefore, it's kind of slowed down by gravity and it's going back. By the length of a pendulum, you are defining the frequency. So the rate, the rhythm of the pendulum is directly defined by the strength of the gravity and by the length of the string. I posted a phone. I posted an app, Firefox. There is an experiment on it. You can attach your iPhone to a string, which is a certain length, and then you can pendule it, and the phone will measure the frequency and tell you some things. However,
Rich,
this is how it works.
With the solar eclipse, it wouldn't prove that the solar eclipse is causing the reverse precession, but I guess it would falsify that it's the Earth precession.
Just
right?
one thing before I read it.
Your like 12-minute long speeches weren't even relevant.
Sorry. So it's the length. It's not the weight. The weight is irrelevant. It's just the length of the pendulum and the amount of gravity that is acting on it. Just one second, and that's causing the frequency.
No. Is it conserving Earth rotation or not? Is it conserving Earth rotation or not?
Let me just bring my one point, and then I will read it. I want to give you the point before I read it. The only thing that changes on an eclipse
he doesn't
is
understand.
that
People's eyes glaze over. Like, it's not interesting.
Fucking just talking about
dog
shit for endless.
I try to.
You're not trying. You're trying to obfuscate into fucking nothing.
No,
man. Is it preserving Earth rotation or not?
I just want to give
conservation
you one information before I read it.
Momentum. That is the point.
I have not read it.
Yes or no?
And I give
stop reading. Answer the fucking question.
I cannot answer that question. I just want to give one sentence.
About my question?
No, about the situation, what happens during eclipse physically.
The globe assertion.
Okay, you're just muting me because you just don't want to hear what I want to say.
I'm muting you because you're retarded and you talk about dumb shit that has nothing to do with this. Is it preserving the motion of the Earth, and is it showing on the pendulum as it precesses or not? Yes or no? Because that's the mainstream claim. It is a physical Earth deviation.
Rix, I have not read it yet.
I'm not asking you to read shit.
He's not even talking about the Elias effect, bro. You're talking about the Foucault's pendulum actual supposedly thing that's happening.
And I just want to give one thing where I think that the eclipse can have an effect on.
Yeah, whatever you want to make us some story about what could happen with the eclipse, but that's not what he's asking you about. He's asking you about the Foucault's pendulum is supposed to persist on the Earth's rotation.
Yes.
Thank you. Was that so hard?
But still, I want to say something about the eclipse situation.
Yeah. You're gonna say the sun and moon are closer there for the gravity of the sun is deflecting it.
No. The moon and the sun are at the same time, so they are in a superposition. Therefore, you would have super tides in that situation.
So you have
that means the moon and the sun, because the moon and the sun are in a direct line towards the Earth. Therefore, the gravity of these both
how much does this
objects
ball weigh?
are
How come I'm not
higher.
getting picked up and thrown to that one side? How heavy is the ball? The lead ball on
So
this
hold on. So
pendulum.
you're saying
just fuck yourself.
Hi, we're Visible. Want to start the new year with some serious wireless savings? Kick off 2025 with Visible and pay just $20